Now let's look at how to calculate bend allowance when you have material that is thicker than 3/16 of an inch. So again, just to review, here's our pair of dies in our press brake. Here's our material sitting in those dies, and there's the inside corner that's going to get bent. When you draw a flat pattern from a formed view, here's the flat pattern, remember that the bend line is always on the inside of that bend because that's where the press brake die comes down. Now when you bend some metal, the outside is going to stretch. It'll be longer. The inside is going to get compressed. It'll be shorter. And somewhere in between those two is a place where the metal does not stretch and does not compress. It stays the same length. And that is called the neutral axis, or some people call it the neutral fiber. And the bend allowance is the amount of extra length that we put in to compensate for the fact that we're going around that rounded corner. Where is that neutral axis? In mild steel, A36, the neutral axis is 0.4 of the thickness of the metal in from the inside of the bend. And let me just say that this is for mild steel. Different metals have different coefficients for the thickness, and you can look them up in Machinery's Handbook. So we're just talking about mild steel. So it's 0.4 of the thickness in from the inside bend. So if we are using 1-inch thick material, 0.4 times 1 inch thick gives us 400 thousandths. The neutral axis is located 400 thousandths in from the inside surface. If we're using 1/2-inch material, 0.4 times the 1/2-inch thickness gives us 200 thousandths. So the neutral axis for this 1/2-inch material is 200 thousandths in from the inside corner. There are also straight segments to add in there. So as a designer, you will figure out how long is that round part of the neutral axis, and then how long is the straight part, and you'll add those two together. Here's an example, and again, this is kind of an extreme example with round numbers just so we can do mental math. So this material is 1 inch thick and it has a bend radius of 1 inch. And the question is, how long is that straight segment? All right, we have a 1-inch bend radius and material that's 1 inch thick, and we're trying to find the length of that straight stuff. We have an overall leg that's 6 inches to the outside, minus the 1-inch bend radius, minus the 1-inch material thickness. 6 inches minus 1 inch minus 1 inch gives you 4 inches. So the straight stuff in this part is 4 inches long. And you are probably seeing how helpful it is to make a rough sketch for yourself. It can just be scribbly on a piece of paper. I do that all the time because I have a hard time visualizing this, so I will make a sketch. You could also just sketch stuff out in CAD, of course. Here on this same part, let's think about how high is the straight stuff over here on this vertical leg on the right side. Again, we have a 1-inch bend radius, and the material is 1 inch thick, and we have an overall height of 8 inches. So what does that mean for the straight stuff? On each end of the straight stuff, we have a 1-inch radius and a 1-inch radius. And then on each end of the straight stuff, we have a 1-inch material thickness and a 1-inch material thickness. So we've got, in this vertical height, we've got 8 inches total minus 1 inch material minus a 1-inch bend radius minus another 1-inch bend radius minus another 1-inch material thickness. That leaves us with 4 inches of straight stuff. Let's look at an example here. Here is a small bracket. In this case, our bracket is made out of 1/2-inch thick mild steel. And someone has kindly shown us what the inside dimensions are already, so we don't have to figure that out. So inside to inside, it's 2 3/8 on each leg of the bracket. And we have a 3/8 bend radius, so that's the nose of our press brake die. Let's figure out the flat pattern. And here's what we're going to come up with. Before the thing is formed, it looks like this. And notice again, I've indicated with a leader line. Here's the bend line, bend up 90 degrees, and here's the bend radius. Our first step is to figure out how far it is to the neutral axis. If this is 1/2-inch material, then 1/2 inch times 0.4 of the thickness gives us 200 thousandths. It is 200 thousandths from the inside of the bend to the location of that neutral axis. Now let's figure out what the radius of this curved neutral axis is. We have a bend radius of 3/8, that's the press brake die, and then we also have a neutral axis, that's another 200 thousandths in, so we have 3/8 from the center of this curve, 3/8 radius and another 200 thousandths distance. 3/8 plus 200 thousandths gives us 575. The bend radius of this neutral axis is 575 thousandths. There it is. There's our bend radius at the neutral axis. Now let's find the circumference of that circle at the neutral axis. And we're remembering that the formula for circumference is 2 pi r. So 2 pi and r, the radius of our neutral axis thing, in this particular example is 575. So 2 times pi times 0.575 gives us 3.613 in this particular example. But we're just looking at this curve that goes around the corner. That's 1/4 of a circle. So let's take the circumference divided by 4. We want just 1/4 of that circumference. So 2 pi r divided by 4 gives us 903 thousandths in this particular example. That is the bend allowance for this part, 903. But when we put this piece of plate in the press brake, that bend line, the place where the nose of the press brake die comes down, is in the middle of the bend. So really we don't want this entire 1/4 circle. We just want to go to the middle of that 1/4 circle. In other words, we just want 1/8 of that circumference of that circle. So if you like, you could skip that previous step where we did 1/4 of the circle and just go straight to the circumference of that neutral axis circle divided by 8. That's how far that curvy thing is from where the straight stuff ends to the middle of the bend. That segment right in there. Now we need to locate the bend line on your flat pattern. For that we need to know how long is this straight segment, and we're going to add that to this round thing. Okay, for the straight segment, we're told that the inside of this bent piece is 2 3/8 from the end all the way to the inside of the bend. But part of that is this 3/8 bend radius. So how much of this is straight? 2 3/8 total minus 3/8, that's the bend radius, leaves us 2 inches that is the straight part. And we are going to add that 2 inches plus that 1/8 of a circumference, which in this example was 0.452. So the location of our bend line for this part is from the edge of our flat bar, 2 plus 452, all the way to here to the middle of the bend. It is 2.452. That's where our bend line will be on this particular part. And so here is our flat pattern. From one end of the flat bar up to that bend line is 2.452. This particular part happens to have 2 legs that are an equal length. They're both 2 3/8 inside. So we know that it's another 2.452 from the bend line to the other end of the bend. So 2.452 plus 2.452 gives us an overall length of 4.904. We don't have to figure this other leg. It's 2.452 also. So here's our finished flat pattern for this particular part. This is all we need. And many shops like to see a formed view. I would say most shops want to see a formed view in addition to the flat pattern, because your press brake operator needs to check their finished piece and make sure that when they put the line here and they bend up 90 degrees at this bend radius, they want to make sure that they really come out with these finished dimensions that you needed, because after all, those are what really count. That's what you need your finished part to be. So for that reason, we usually give our shop a flat pattern, which I've labeled, and a formed view, which I've labeled. And what you will do, I'm sure, is go out and talk to your shop and find out, what does your particular shop want? Is that what they want? Do they want these things here? Or do they only want the flat pattern? Or in some cases, I have actually worked with shops where they are very proud of their professional skills and they don't want a flat pattern, which is just another potential for things to go wrong. I have actually worked with sheet metal people who want just the formed view. So don't assume anything. It's one of the fundamental rules of drafting. Never assume anything. Go out and talk to your shop and find out how they want your drawing done. But this is how you figure out the bend allowance and where to put the bend line. Now let's go look at our actual quiz that we'll be doing.